Hello.
Can you see me? I don't know how this thing works.
Not at all.
Oh, that's good. Let's see. Oh, okay. Okay.
There you are.
Here I am. Okay. Let's see. Okay. So, what's your name?
Axel.
Axel. Okay. Well, I'm Julie. And then I don't know what happened to the other group member.
So she said last time that she was going camping for a week.
Oh, okay.
So I don't think she.
Yeah. Let's see. Do you have any? I think we're just supposed to go over the group activity that's today.
Mhm. Yep,
Right?
I think so
Yeah.
too.
Two. Okay.
So let's see.
Just finished watching the video.
All right, cool. So yeah, we're just kind of. Have you watched the video yet?
Yeah, I just watched it.
Okay, cool. So I just watched it not too long ago, and did you have any like questions about it?
Hmm. I don't think so. It's kind of so. I guess so. What it's trying to do is it gets the same integral on either side, so then you can add those
Mhm.
together, right?
Right.
So you have to wait till it gets.
Mhm.
Okay.
So I did the homework for today,
Yeah.
and I guess the only thing that was like um, really weird for me is um, I guess sometimes it's better to choose the trigonomic part of the function as u, and other times it's better to pick the other part as u.
Yeah.
Um,
That was. Yeah, I was wondering. Does it just depend on the problem?
yeah. So like sometimes, like if it was x cosine x, then you would obviously pick x as u because then du would just be dx.
Yeah.
And so it would simplify the problem and you wouldn't have to solve for like a second integral. But when it's problems like EDX, then you have to like go through multiple steps and make sure you factor out the right things and that you have your signs right. Um, and then you eventually get to the same integral that you started off with. And
Okay.
it's kind of interesting how it works.
Yeah. That's kind of interesting. Or you just keep
And
going.
this one's like a simplified version,
Yeah.
because you just end up with over two. But with some of the other ones, it's like the integral you'll end up with like a fraction times the integral, and so you'll subtract that, and so you're left with like an odd fraction. So you kind of like pretend the integral is like a variable, and then you just kind of subtract it like you would a variable, but then you multiply by the bottom and then divide by the top. And sometimes a lot of things will simplify, and it's just kind of interesting how it'll kind of decide what your choices are based on that.
Okay.
So have you taken a look at any of the homework yet?
I haven't. Still
It
working
was,
on.
honestly, it wasn't too bad.
Yeah.
The integral of sine x times sine 11x. And so you picked like sine x is u, and then sine 11x is dv. And you just like went from there, and you just kind of kept solving and solving until eventually you got the right answer. But it was just a little interesting.
Yeah.
So so I think another is the practice with parts.
Wait, what'd you say? It was choppy.
So it looks like another part of the activity is practice with parts and trig worksheet in step 2.
Yeah.
Have you taken a look at that?
Yeah. So. Okay.
Do you have that up?
Yeah, I'm looking at
Cool.
worksheet.
Mm-hmm. I figured it might be beneficial if like we just kind of ran through them really fast and just talked about like which one would be U and which one would be DV. And I think that
That'd be good. Yeah.
that would probably down later. There's a little bit more complex problems, but
Okay.
so the first one's pretty straightforward. Of the integral of x sine x, u would be x, and then dv would be sine x. And so, I mean, I can talk about the odd ones if you want to talk about the even ones.
Sure.
Cool.
That's good. So. So on. Let's see. Okay. On this one, would you want u to be sine x squared? Does that work out better? Okay.
I think if u was x, then du would essentially just be 1. And so it would make it a little simpler.
And then, so you find u, and then du. So I'm trying to remember. Okay. And then. So then dv would be sine x squared, and that would make. Let's see.
There's an echo.
Hey, I can't talk right now because I'm doing a group meeting. Okay, that's okay. But do you want to come over at like 6 or 5:30? 5:45? Maybe. Maybe later. Closer to 6. Okay. Yeah. Okay. Bye. Okay.
No problem. Actually, so I was
Trying to think.
just looking and I realized that derivative of it's like, yeah, so if you were to take the derivative of it would be x times cosine x, which means that this one should be like 1/2 negative cosine x squared, because if you were to take the derivative of that, it would be sine x squared times the derivative of the inside, so times x, the derivative of x. And so you already have that x out there.
Okay.
So it's like you don't need to do the u dv substitution. You just need to kind of do almost u substitution. If x squared was u, then du would be 2x
Oh,
dx. So
okay.
you can, so that one's really not too bad. Number 3, however, you would have to pick, you'd pick x cubed minus x as u and x squared as dv. And do you understand that little trick that they do?
I
The
think
little
so.
shortcut process? So I looked over it a few times and I finally understood it. And I used it once or twice and I actually got the answer.
Okay. Yeah, because I just barely.
So,
Kind of.
right. Let me see if I can find a good page. So if you pick x cubed minus x as u, then you can write that. You can do x cubed minus x. And then below it, write the derivative of that, which would be 3x squared minus 1.
Okay.
And then write the derivative of that, which would be 6x. And then write that derivative, which would be 6. And then write that derivative, which is 0. So as soon as you hit 0, that's where you want to stop.
Oh.
And then on the other, you can make like another column. And on that side, you want to write your dv, which in this case is sine x. And then you want to write the integral of sine x, of cosine x.
Negative.
And make sure you're writing those like at the same
one
level as you wrote the others.
Yeah. Okay. And then do you just keep finding the integral of those till you go
right
down?
So then the integral of negative cosine x is negative sine x. The integral of negative sine x is cosine x. And then the integral of cosine x is sine x.
Sine x. Okay.
What you do
And then
a diagonal line like this.
yeah. Okay.
And so those will match up. And the first line, you'll put a positive. The second line will be a negative. Third line will be a positive. Fourth line, a negative. So it's like that.
Okay.
So then you multiply those. So you do x cubed minus x x cubed minus x, close parentheses, times negative cosine x. And then 1 times a negative sine x. And so it's a positive. Those two negatives cancel each other out. And so you get plus 3x squared minus 1 in parentheses times sine x.
Okay. And then
Just keep doing that. And you get plus 6x cosine x and then minus 6 sine x. See that?
Yeah.
Well, that's the answer. And so it takes a few steps, but that integral. And that is so much easier than writing it out step by step.
That is a lot easier.
Yeah. And so if there is to the integral, I highly suggest doing it this way.
Yeah, I liked that a lot more. It's a lot
Yeah,
more
and,
simple to figure out.
right. And at first I was like a little like leery of it. I was like, I'm not exactly sure if this is like how it's going to be, but then I actually did it. And then you should probably like multiply it out and then like simplify, but this will give you the correct answer.
Okay.
And so do you want to do number 4?
Sure.
We can walk through it and see if we get the same answer.
Okay. Let's see. So I want you to be x cubed minus x.
Mm-hmm. And so in this case, the integral of cosine 3x will be 1/3 sine 3x.
Yeah. Okay.
And so you
1/3. you get through it?
Yep.
Okay.
So what did you get?
So I got here. So x cubed minus x sine 3x over 3,
Okay.
right?
Yep.
Plus 3x squared minus 1 cosine 3x over 9
Mm-hmm.
minus 6x sine 3x over 27,
Mm-hmm.
and then minus 6 cosine 3x over 81.
Perfect. That's what I got. And then I just simplified.
You just simplify it, go through over each one.
Yeah. Once you simplify, you end up multiplying it all out, and you get x cubed over 3 times sine x 3x. So sine 3x minus x over 3 sine 3x plus x squared over 3 cosine 3x minus 1 over 9 cosine 3x minus 2x over 9 sine 3x minus 2 over 27 times cosine 3x. But that's just multiplying it out and simplifying.
Yeah.
So, but yeah, I mean, that's how you do it. And it honestly makes it so much easier than trying to go through and write the integrals and yeah. So
Okay.
one thing that I learned from doing it this way is that if you have to integrate multiple times, stay consistent. If you pick a u, make that your u for everything. And then if you pick a dv, make that just dv for everything. V's are always v's and u's are always u's, and it just makes life so much simpler.
Okay.
Number 5 looks like a pain. So this is one of the ones that you'd have to kind of write out. And so if e to the x was u, it means du would equal e to the x. And then if dv was cosine e to the x, that means that v would equal 1 over e to the x cosine e to the x. So then if you actually multiply this out, you end up getting u times v, which is 1 over e to the x times e to the x, or just 1, times cosine. Oh, sorry, my bad. If dv is cosine e to the x, then v is 1 over e to the x sine e to the x. That was my bad. So you have e to the x times 1 over e to the x times sine e to the x, which just simplifies to sine e to the x, minus the integral of actually,
Wait, this one?
it's interesting. Just a second.
I pulled up the answer key.
And e to the x, right?
And it just says sine e to the x plus c.
Right. Yep. Okay. No, that's perfect. Because I was looking and I was like, because I realized ex is du. So if you have if sine e to the x, if you take the derivative of that, it ends up being e to the x times sine cosine e to the x. That's interesting. That actually makes sense. So it's a little odd, but it still works because sine e to the x minus, or sorry, sine e to the x plus cosine e to the x is, that's odd. I don't know. It's weird. The whole u dv substitution, it can get a little tricky sometimes. But luckily you don't have to use it here. However, in the next one, we do have to use it, number 6. I think we can do number 6, and then I think we kind of got the gist of it.
Good. See number 6.
So if e to the x was u, so u equals e to the x, du is e to the x, and then dv is sine to the x, which means v equals negative cosine to the x. And then you get e to the x cosine x minus the integral negative cosine. And so the negative outside the integral and the negative in the inside the integral, they cancel each other out. So we have 2 positives now.
Right, so you do, I'll read this lot. So to the outside, you have, it's u times v, right?
Yep,
So,
u times v. And then the new integral will be du times v.
Okay.
And since there's a negative sign outside the integral and a negative sign inside the integral, they cancel each other out. Because it's like factoring out a -1 and timesing it by the negative, which just makes it positive. So we end up with negative e to the x cosine x plus the integral of cosine of e to the x cosine x. So if we do the same thing and we pick u equals e to the x and du equals e to the x, then dv equals cosine x, then v would equal sine x.
Okay.
And so you multiply that out and you get e to the x sine x of e to the x sine x, which is the integral that we started with.
Okay. So
now we can add sides and we get 2 times the integral of e to the x sine x cosine x plus e to the x sine x.
wait, so it equals the negative ex cosine x?
Yeah, negative e to the x cosine x plus e to the x sine x. And then you'll divide that by 2. So it should look like that.
Okay.
So I think this is the one that they walk through in the tutorial. Or something similar to it.
Yeah, it was something kind of like.
So cool.
That's good. I feel like for like my tutor because that helped a lot.
Oh yeah. So I took calculus in high school.
Oh, that's good. I really wish I would have done that.
Yeah, I'm taking calculus again because right after high school I served my mission and I just forgot everything. So last semester I actually took pre-calculus.
Yeah, I took pre-calculus fall semester.
Fall semester. Okay. What track are you on?
I'm on fall winter, but I took this winter off, and I'm just taking
Got it.
this online right now.
Cool. Are you at home or are you staying here in Rexburg?
I'm in Idaho Falls right now, but I'm
Okay.
moving back home in a couple months before I come back up.
Got it.
Yeah.
All right. Well, that kind of basically covers it.
Yeah.
So there wasn't anything harder than that on the homework. Not really.
Okay.
There were some odd ones that like it took a little bit of thinking to do, but honestly, if you can remember the trick of like how to go down the list and do a few things, that makes it so much easier.
Okay.
So cool. Any other things that you feel like we need to go over?
I think you're good.
Cool.
Okay. Well, I think
We'll go for it.
so. When I stop the broadcast, do you want me to just email you the link?
Mm-hmm. Yeah,
Okay.
that'll be perfect.
Okay. Sounds good. Well, thanks for meeting with me. And then I'll just send you the link.
Perfect.
Okay.
All right. Well,
And
yeah,
then
I think
I
that's it.
guess, yeah.
We
And
just
then
fill out the report and put the link in.
yeah. And then the next couple of weeks, it's every 2 weeks, right? So are you next 2 weeks? I don't know.
I can be.
I don't know. It doesn't matter too much.
Yeah,
Okay.
no, it honestly doesn't matter to me. So I can do weeks.
Okay.
Cool.
Sounds good. Okay. Well, see you next week then.
See you next week.